Today, let's explore the physics behind the crumple zone.
What is crumple zone? Crumple zone is a part of a motor vehicle, especially the extreme front and rear, designed to crumple easily in a crash and absorb the main force of an impact. History of crumple zones. The crumple zone concept was invented and patented by the Austrian Mercedes-Benz engineer Bela Barani originally in 1937 before he worked for Mercedes-Benz, and in a more developed form in 1952. Looking at photographs with car accidents that took place in the 1950s and accidents in more recent times, you think that engineers have gone backwards and have made vehicles less safe. Crumple zone uses Newton's first and second law. Newton's first law states that an object in motion will stay in motion with the same speed and direction, unless it is acted upon by an unbalanced force. Newton's second law states that a force is equal to mass multiplied by acceleration.
If translated to a real-life example, it would be, if a vehicle is traveling at 50 miles per hour, so are the bodies inside. If this vehicle stops abruptly into a solid wall, and the bodies will feel the need to keep going in the same direction at 50 miles per hour. Unless, of course, something stops them. Here comes Newton's first law. However, such injury could be prevented by the crumple zone, a part of motor vehicle that is placed at the front and the rear of the car and can delay the collision by increasing the time before the vehicle comes to a halt. According to Newton's second law, the force experienced by the automobile and the passengers will significantly decrease as the crumple zone created more time that required the vehicle to stop.
Let's do a simple problem. Two cars are crash tested. Car A has a crumple zone, B doesn't. Both cars have a mass of 1,500 kg and a driver of mass 80 kg and a crash at 20 meters per second. Cars A and B take 0.8 and 0.2 seconds to stop respectively. Using this information, are crumple zones a necessity?
Using the velocity before crash and the mass of car 1, we can calculate the momentum of car 1 before crash, which is 31,600. Since the velocity after crash is also 0, then the momentum after crash is also 0. Therefore, the impulse of car 1 equals to the change of momentum is also 31,600. Reorganizing the formula for impulse, we can calculate the force on the driver when the car crashes by using impulse divided by the change in time, which is 0.8 for car 1, and the calculated result force for car 1 is 39,500 newtons. Now repeat this process for car B and compare the results. Force acting on the driver in car B during crash is 158,000 newtons. In conclusion, car A has crumple zones that increase the collision time. This significantly reduces the force on the driver and makes the car much safer. Therefore, crumple zones should be a legal requirement. And impulse. By increasing the time taken to change the momentum in your crash, the crumple zone reduces the force involved during collisions. The formula of impulse is J is equal to F multiplied by changing T. After recognizing the formula, the force on the driver can be calculated by F is equal to J divided by changing T. According to this equation, as the change in time increases, force acting on the driver decreases. So the crumple zones are designed to crash in a controlled way in collision. Crumple zones help to form an elastic collision, a collision in which kinetic energy is not conserved due to the action of internal friction. The force acting upon the driver is significantly reduced, and thus the driver can be safer. Thank you for watching. Hope you learned something about crumple zone in this video.